All right, everybody. We're all set up. So already on stage is Cody Burns. He's a blockchain architect at Accenture and longtime ETC community member. He's going to be giving a live IoT demonstration on stage. So big round of applause for Cody Burns.
Good afternoon, everyone. I'll go ahead and apologize in advance. IoT demos generally fail, but this one won't. I promise everything will go through. So as Anthony said, my name's Cody Burns. I work with Accenture. I'm a blockchain architect. What that means really is that I'm working with the emerging technology group. So the technology that we're interested in is the stuff that enterprise companies will be using in the next 5 to 10 years. Augmented reality, artificial intelligence, blockchains, and big data are our focus right now. My primary focus is with IoT and specifically with blockchain and how that works with companies. So as I said, I've been with Accenture a year now. The demo that we're about to see came out of work I was doing last year around this time. So whenever Bitcoin was still really low in value and no one was really interested in it, I started paying my kids' allowance in Bitcoin. So that worked out very poorly in the long run once it hit $20,000. So about this time last year, I needed a way to get the Bitcoin back from them ethically without stealing from their piggy bank. So what I'd come up with was Halloween was coming up, and we had a pumpkin out front, and we wanted to be able to shoot flames out of it. So they had a QR code they could scan and send their ether to, and then shoot fire out of the pumpkin. It was fun, but you can't really bring flamethrowers shooting pumpkins on international flights. So today, we'll be using a lamp, turning it on and off. And how this has evolved now, inside of our house, we have our Alexa hooked up with all of the IoT devices, along with the blockchain. So this is something that we actually use and play around with in our house. So the way this technology is going to work in the future is going to need some sort of scaling solution. So it's not practical for 200 million devices to be turning on and off on a public blockchain right now. So it's not practical for 200,000. It's not practical to run a data center, really, on a blockchain at this point. So scaling solutions are very important, and that's one of the big focuses that I work with at Accenture. So a lot of the talks during today is we've come across consortium networks and enterprise networks, and that's where our focus is. So what Accenture's been doing over the last couple of years is we've been building an army of blockchain architects. So as you can see, we have over 500 people, 500 plus in our India offshore delivery centers. We have 125 plus projects that have been delivered globally as far as proof of concepts, all the way through pilot implementations. We've worked with banks for financial solutions. We've worked with transportation companies, and we've worked with identity solutions. We have currently 50 plus active blockchain engagements globally, and 70 plus clients being served. So the technology that we focus on right now is Hyperledger, multi-chain digital assets, Ripple and Quorum, and the Ethereum enterprise. So at the end of the day, whenever someone uses a system, the way we can tell that I've done my job is that you don't know that you're actually using a blockchain underneath. It works exactly the same as a legacy system does. It just provides all the auditability and trust that we all preach about in the blockchain. So it's rewarding, and it's also not rewarding. There's a lot of businesses that look at blockchain. They've heard the hype over the last year or so. And once they actually get into the system in reality of what they are, they find out that they might not actually be the product they've been sold. So the biggest selling points for us are still the auditability, it's still the trust, and it's still the secure technology. And that's what we really try to bring to the public. So one of the things that we talk about whenever we talk about IoT is, as I said, every device doesn't need to be on the blockchain. The edge is where the activity really happens. So one of the things that really bothered me, and it bothers other people, whenever I have a new light or lamp or thermostat or security system installed in my home, it's not just me and my light. I can walk over and turn my light on and off by my hand, but to do it with the phone right now, I have to send a signal to a cloud server, and that cloud server decides whether or not it's going to turn my light off by sending a signal to my house. If someone breaks into my house, it sends the signal from my house to somewhere, could be a data center in the West Coast, before it alerts me. So one of the big promises of blockchain is that we're able to keep the data, keep the technology more simple. With me and my light, it's just me and my light in a blockchain. So everything that we do is stateful. It's at the edge. So in my house, I have one of my routers is converted into a gateway. It runs the Ethereum Classic parity node, and it's constantly syncing. So all the smart contracts on there that are controlling everything in my home get their signals from there. They know what their contract addresses are. They know what their states are. And for all of mine, they're on timers. So that's what I use smart contracts for. So how this would move out towards the real world. So a city could decide to make all of their intersections smart intersections using a blockchain. You wouldn't have to have somebody go out and reprogram the intersection controllers every time that new software came out. You could remotely change light patterns. If there was a parade coming up, you could send a signal to 30 different intersections of this is a new timing pattern. You can get the data from those sensors in a secure way and guarantee that as the updates happen, they're done in an auditable way so the public is aware of everything that's going on. So illustrative use, as I said, the edge is where the data analytics is going now. So many of you have probably seen these smart parking lots, and I won't go too deep in how they work because I only have 20 minutes left. But so they're able to tell you which parking spots are full, which ones are not. The older systems use the same technology as a metal detector used, and it was a dumb system. So the new systems now use video analytics to tell exactly who's parked in a spot, how long they've been parked there, and you're able to do analytics on that on a massive level. So you don't have to worry about just one parking garage. You can control an entire network of parking garages. And where the blockchain solution fits into this is making sure that that data is transmitted in a secure way and that it's actually the equipment passing the information that claims that it's passing the information. Before we get into that. So one of the big promises of the future is the digital twin of our devices. So we won't just have a computer or IoT device sitting at your house. It'll have a digital twin on a blockchain. And that digital twin is able to track the entire life cycle of it. So if you add software to it, or if a new patch comes out for your car, you're able to monitor that in real time, and automotive industry will be able to send the cryptographically verified firmware to update your car's computer. And they will be the only ones that have the private key that can send that information to the cars that they own. And you don't have to wait for a recall to come out. You don't have to wait for a security audit. You don't have to check an obscure website whenever you're trying to find this information out. The standards are already in place. We just have to incorporate it with the blockchain. So the IoT demonstration. I understand that we have people with time delays and lags, so I'll try not to get too deep into the boring parts of it. So we're going to go through a simple hello world version of a contract. So this is also on my GitHub if you need to reference it. So basically what we do is we start a new contract, we give it a state, on or off, and then we give it two functions. It's simply on or off, and we're able to call those functions. We also have an event alert that's called alert. So anytime a state change happens, whether it's turning on a device or turning off the device, we're going to log it to our console. So this is a Paradig's client, if you're not familiar with it. This is their contract IDE. So as you can see, I've been testing it a lot because it's a live demo. So off stage, which we don't see, is there's a Raspberry Pi that's running a constant program that's calling its contract and checking to see what state it should be in. Now this could be on or off, or this could be what software version it's supposed to be running, or what time it's supposed to be turning on and off as a timer. And it's connected to a surge protector off stage, and it just controls the flow of electricity through it. The program for the actual Raspberry Pi, it has a contract address at the top. It has information with how to interact with Web3, and then it's just a simple timer. It calls its contract, it sleeps for 5 seconds, then it calls it again to keep getting the signal. And it does this all day long, every day. So from the blockchain point of view, whenever we want to execute a function like turn on the light, it has a human-readable version. This is the moment of truth where we wait for the blockchain. As I said, it would probably fail the first time. It looks like my Raspberry Pi has gotten bogged down. But we'll give it a second to restart. So as you can see, it logs the entire event as it happens. So we can give real-time logging of whether a device is turned on, whether it's turned off. And the only person that can control this light right now is the owner of that light. So I don't have to worry about anyone unauthorized being able to see if my lights are on or off at my house. I don't have to publish the contract if I don't want to. Everything is just bytecode sitting on a blockchain. My address is still synonymous. It was generated as I was sitting over at the desk earlier today. So there's nothing that actually ties this device to my house or to me in any way other than I own it and I know the contract address. And that's a huge benefit whenever it comes to IoT devices. As I said, I don't have to worry whenever I order a new device off eBay of having to download a new app or sign up for another service or have another third party monitoring my data. I'm in control of it. And what this also means is that we can also monetize this data. So being that I know how many devices I own and what type of devices they are, we'll be able to sell that data to other people. So if there's a company that's really interested in doing analytics on how garage doors work or how often someone opens or closes the garage door, I can prove that I have the bytecode that controls the contract that opens and closes my garage. Let's refresh one more time. All right, and while that's restarting, I'll take some questions. Like I said, I apologize in advance because this seems to be the nature of it. I've been testing it for the last hour over there, and as you get on stage, this is what happens.
All right, do we have any questions? Okay, so I have a question. How many lines of code is this? Like, how much effort is it to, besides the demonstration, to actually get something like this to work? I mean, I've seen the flamethrower, so I can vouch for it. The flamethrower did work, and it's pretty awesome.
Right, so this entire IoT demo is under 40 lines of code for the hello world. If you're just new to Solidity programming, you could do this in probably 10 or 15 minutes as an introduction to programming.
Yeah, that's great. Can you envision any applications where maybe it requires a bit more lines of code, but it does some other neat things, like? Sure.
So as I said, at my house, I have this same setup, and It's also configured through my Alexa. So I can ask Alexa to turn the light on and off and have it also be logged on the blockchain. Using Alexa also, you're able to have your wife be able to turn something on and off, or you can see who's in control of the data and who's activating the device.
So you can see who left the lights on.
You can see who left the lights on and finally solve the problem. Yep.
Oh, a couple more questions over here.
Yeah.
Hey, Cody. So one of the earlier companies that I saw first involved with blockchain was actually IBM with Project Adept. It was actually IBM and Samsung in early 2015 looking at IoT, sort of edge computing, things like this. So they had this demo that they did at CES in Vegas where they had a washing machine buying its own detergent. And the other one that they had was they had a smart contract to do with servicing agreement. So you had a washing machine detecting a broken part and basically like seeing that it had service coverage for that and scheduling an appointment to get someone to come in to fix it. So I'm just wondering, I mean, that was early 2015 sort of stuff. Have you seen other large electronics or other large companies, doing IoT blockchain pieces more, or is it all still, really early days?
So I think what the big trend that we've seen lately has been companies knowing what to put on a blockchain and not to put on a blockchain and being more smart about the data management. So with the public chains, there's only so much space that a computer is going to have. We can't have an infinite size of our state. So that's one of the reasons that Ethereum on the public chain has cost and not in a consortium chain. So knowing the difference between what should be stored on chain and not stored on chain, I think is the biggest trend that we've seen in enterprise right now, is that there's been a real, I guess, coming of age of realizing that you can use a blockchain and you can also use other systems incorporated with it. And that integration has been one of the biggest improvements over the last 12 months, I would say. So I guess learning what the system is and what it isn't.
You don't need global consensus for every data item in the whole world and every event, every button click that anyone does.
Yes, every button click on a website doesn't need global consensus and doesn't need a $2 billion network.
Correct.
Only things that really have lack of trust between two parties or footfall events. So one of the proof of concepts that we built out was tracking medicine from moving from the manufacturer of the medicine all the way through to where it was distributed to patients. And it has to be refrigerated at a certain temperature. However, we don't need to store immutably forever a temperature every 5 seconds along the way. We only need to really store the data whenever it falls either above or below the threshold. So when that happens, that's an event that would be considered a blockchainable event, for lack of a better term. So something where there could be a dispute, and you would need the immutability and auditability of a blockchain. And so that's, I guess, the biggest trend that we've seen lately.
And I guess permanence as well, right? Because you're basically sort of saying this is a thing that I want to be stored forever and ever, but things may not have value forever.
Exactly. So the blockchain can become Exhibit A in a court case if it needs to be, and it can be the witness that no one's ever tampered with. That's something that we haven't had in systems before. Earlier, someone had asked about why don't we just use databases that we've used for years and just provide access controls to them, or role-based access. And that's one thing that the blockchain provides that we haven't been able to provide before, is that ability to have the tamper-proof system. Are there any other questions?
Yeah, I have a question. My hometown of Kansas City recently, I think maybe it was last year, ran a pilot where they installed a large number of sensors down a strip of road, and they basically wanted to start like a smart city project, but didn't, I don't think, know exactly what they were hoping to get out of it, and were trying to, come up with something. And there seemed to have been some disillusionment that came out of that. They weren't quite sure what the outcome should be. And I think what they came up with was using the sensors to detect the right place to predict where there's going to be potholes in the road. Like that was the big outcome. So you mentioned smart city, I think specifically around managing stoplights and things like that. What are other use cases for smart city that you're seeing that you're excited about, and how does blockchain play into those? Does it kind of expand what you can do in the smart city context to use blockchain?
Right, so I guess one of the biggest things that I'm excited about, just because my background's in oil and gas and energy, is the electrical grid. So the electrical grid right now is horribly outdated. We haven't had infrastructure upgrades in many years. We still have cities that have power lines that are above ground, so every time there's a storm, limbs fall on it, and we have to send out armies of people to figure out which power line went down, where it went down at, and that's something that could be solved. That could be the footfall event, using simple sensors that have 3G access. So they could use cell phone towers or simple radio communication and relay globally or back to their home center of what's wrong, where it's at, and how to route power around it. And that's where the blockchain part of it would come in, because you could do the routing of electricity around down areas without having to do all the legwork that you're having to do now. So the grid's something that's very interesting to me. Larger term, grid scale storage, it's not something that's really being handled at all right now. So if all the power generating factories in the United States shut down, we'd have about 10 minutes worth of power before the entire world went dark. So grid scale storage is a solution that's on the horizon of coming out as well. So having houses that have backup batteries and generators that can charge off solar panel or off regular electricity and then feed back into the grid as the system goes. And that being controlled in a secure and auditable way is very important. Being able to tell the electricity or the electric companies that I know that I've fed back in 16 kilowatts on this day, and here's the ledger that says that you only paid me for 14. So being able to have that auditability trail is going to be very important as we move forward. So using energy more smartly.
Thank you.
Yeah, it's dead. Are there any other questions?
I have a small one, just very typical thing for debugging. Have we made sure that it's on, like the power switch?
Yeah, it was. Yeah, unless it got, yep, everything's still going. It's just got stage fright. That happens to blockchains.
All right, do we have any more questions? Right back there.
Hi. I have a bit of a technical question. So the sensor node that you have here, it's Raspberry Pi plus the lamp, right?
Yes.
So how does it interact with the blockchain?
So the node's running a Web3 stack, so it's pinging my server that's back at home, and it knows its contract, and it knows the ABI code. So the ABI has all the functions that it's able to do, and it just calls its functions to check what its status should be. And then it checks what its status is, and it compares the two. If it's supposed to be on and it's off, it turns itself on. If it's supposed to be on and it's on, then it stays on. So it's just a simple logic contract. It's running with Node.js.
And one more question, sorry.
Mm-hmm.
So if we go for the low power, is it applicable in this state?
Yes, it is. So Sputnik VMs, one of the exciting things that has come out of ETC Dev as far as the low power option goes. I had a similar setup with this, except with the Raspberry Pi Zero and a solar panel, and it records the moisture that's in my garden, and it just sits out there on a solar panel, and it's able to keep up with the blockchain, and that's running a full node on its own.
Okay,
So,
thank you.
yeah, low power is very important whenever we talk about IoT.
Yeah, that's true. Okay, thanks.
Okay, awesome. Anyone else? Okay, I guess we're good. Thanks, Cody.